Hi friends, here is a beautiful problem. We are given this function f of x equal to greatest integer function of x sine pi x. Then we have to discuss about the continuity of this function. Okay, let's try to break the problem. First, let's start with sine pi x. Okay, then we'll go to x sine pi x, and after that we'll go to greatest integer function of x sine pi x. Let's go stepwise. Firstly, sin x will start even before that. Even before sin pi x, let's start with sin x. What is the graph of sin x? Sin x graph will look something like this. Right. It will repeat itself after every 2 pi units. Right. This is 0. This is pi. This is 2 pi. And then again after 4 pi, likewise. Okay. The period of sin x is 2 pi. It will repeat after every 2 pi units. Right. What about sin pi x? Sin pi x is a compressed version of sin x, right? So it is compressed pi times. It is compressed, whatever this 0 to 2 pi is actually compressed. For example, sin 2x is 2 times compressed of sin x, right? Or this is compression in this way, right? Now sin x, if it is x, the period is 2 pi. If it is 2x, the period is pi, because 2 pi by 2, which is pi. If it is 3x, then 2 pi by 3. Similarly, if it is pi x, it should be 2 pi by pi, which is actually equal to 2. So sin pi x is a graph that will repeat itself after every 2 units. Right? It looks exactly the same, but instead of 2 pi, it is actually 2. This is 1. Right? Again, this is 3, this is 4. It repeats itself after every 2 units. Okay. So I'll show you the graph. This black one, this one is sin x. It is repeating itself after the 2 pi units. This is 2 pi, right? 6.2. 1 pi is 3.1, right? This is pi. This is 2 pi, right? Now, this brown one or this red one, this is actually sin pi x. Sin pi x, the period is actually 2. That means the cycle is completed. It will take 2 units to finish each cycle. So 2 to 4 another cycle, 4 to 6 another cycle. So similarly, 0 to minus 2 one cycle, minus 2 to 2 minus 4 is another cycle. Likewise, this is sin pi x graph. Okay, sin pi x, we have reached till sin pi x. Now we want to see x sin pi x. X sin pi x. What does that mean? We are multiplying this graph with some x. Right. When we are here, x is 0. Right. When we are here, x is 1. When we are here, x is 0.5, here 0.3, here 0.7, whatever. When we are here, x is 1.2, 1.5, 1.7, 1.9, whatever. Okay. So we are trying to multiply this graph. This graph, when x, we are trying to multiply with this graph with x. Obviously, when it is 0, it is 0. When it is 0.5, it is 0.5 into this one, it is somewhere here 0.5. When it is 1, 1 into this graph again. This is 0, so it is 0. So it goes something like this. Okay? It goes something like this. Now, similarly, what about between 0 and minus 1? Here, this graph is 0 into 0, that is this one. Then this point is minus 0.5 into minus 1. That is again plus 0.5. And this point is again minus 1 into 0. So this is also equal to 0. So towards the left side, it looks something like this. Something like this. Okay. Now here, from 1 to 2. 1 to 2, we are multiplying this point with 1. This point with 1. And this point with this one with 1.5. And this one with 2. So this point is here only, and so it will go like this, something like this. Now between 2 to 3, you'll start with 2, you will go up to 3. So here it will go even bigger. Okay, so the graph will look something like this. Okay, so this one looks better, right? Because this is a properly drawn graph. So we start with 0 to 1. It will go like this. Okay, so that is sin pi x graph multiplied with x, that is this one. It starts with 0, it ends at 1. So it will end at 0 again here. Right. Now, it starts at 1. 1 times sin x. Sin x, 1 times sin pi x. Sin pi x is something like this. Sin pi x is something like this. Right. Now we are multiplying with this one. So clearly this point is what? This point is 1.5, and 1.5 minus 1, this is minus 1.5. Right. It goes like this. Similarly, this point is 2.5. 2.5 into 1, this is actually this 2.5. Similarly, this point is actually 3.5. 3.5 into minus 1, because sin pi x is always like this. Right. 3.5 into minus 1, this is minus 3.5. Likewise, this one. So this, as x increases, this wave, this amplitude increases. Right? You can clearly see, right? This part is between 0 to 1. We are multiplying sine graph with 0 in between. So this part you are multiplying with 0, some number between 0 and 1. This part you are multiplying with some number with 1 and 2. So that's why this is bigger. This part you are multiplying some number with 2 and 3. So that is even bigger. This part is again you are multiplying with some number between 3 and 4. That is even bigger. So this amplitude keeps increasing. See, this one keeps increasing, but at the same time, they will have to touch 0 at every integer. At 1 it will touch 0, 2 it will touch 0, 3 it will touch 0, 4 it will touch 0, it will touch 0 at every integer, because essentially you are multiplying this small cup only. Just that the multiplication factor is higher as your integers increase, right? Everywhere you are multiplying with one small cup. The cup highest value is 1, lowest value is minus 1. But you are increasing the number with which you are multiplying. Okay. So now what is this violet graph? Violet graph is x sine pi x. Now are we done? We are not done, because we want greatest integer function of x sine pi x. Okay. We have figured out this x sine pi x graph, which is this yellow. Sorry, which is this violet graph. Now x sine pi x. Obviously this has to be an integer. Right, because this is the greatest integer function, this graph always has to be some integer, some straight lines only. It cannot have a curve, because between whatever segments, this is always an integer. Right, greatest integer function of something, this point of 2.2, 3.3, whatever, this is always an integer. Now, what does that mean? So, between here to here, greatest integer function of this, right, between any number between, the highest is going to somewhere here, and whatever. So the greatest integer function which is lesser than this point, that is this one. So between 0 to 1, the graph is this. Now here this graph is going here till this point, right? What is the greatest integer function of this one? It is somewhere here 0.7. So this point is somewhere 0.7, minus 0.7. This is somewhere minus 0.5. This is, we are talking about y, right? Minus 0.3, whatsoever. Till this point, it is minus 1. Greatest integer function of x sine pi x. Till this point, it is minus 1. Then, because once it crosses minus 1, from here to here, it is crossing minus 1. Right, once it is crossing minus 1, so this point is somewhere minus 1.1, 1.3, 1.5, whatsoever. So, for that, the greatest integer function is minus 2. So this part is actually minus 2, right? So these black lines, again from here to here, right? The value of this graph is somewhere between minus 0.9, minus 0.5, minus 0.1, whatsoever. So this is this graph, right? Again, this one. So it is crossing 2. So till this part, whenever it is crossed 2 and staying below 3, the greatest integer function of this function, greatest integer function of x sine pi x is this one. Similarly, between this line, this point and this point, it should be this one. Similarly, between this point and this point, it is this one. Right. So, similarly, between minus 1 and 0, that is this line. Because whatever, this point is 0.5 or 0.3 or 0.3, 0.2, 0.1, whatever that is, greatest integer function of this one is actually equal to 0. So essentially this graph is actually a set of straight lines, set of this small straight lines, and they are breaking at multiple places. Whenever this function is crossing some integer, whenever it is crossing some integer with respect to y-axis. It is crossing -1 here, it is crossing -2 here, it is crossing -3 here, it is crossing +1 here, +2 here, +3 here, +4 here, likewise. So whenever this graph is actually crossing an integer in y-axis, you will get a small line, right? You will get a small line. So this function, this graph of this function actually is a combination of these small lines and breaks at multiple places, and definitely you can see there are breaks and definitely at every integer, right? There is a break before and after every integer. You can see this, right? So before 1 it is this, after 1 it is this. Before 2 it is this, after 2 it is this. Before 3 it is this, after 3 it is this. Likewise, right? Even between integers also there are breaks, but at integers definitely there are breaks. Okay, so now the question was actually much simpler. We didn't need to analyze the entire graph of the entire function. You are just asked whether it is continuous at x equal to 0 and between -1 and 0. Right, both are open brackets. This is open brackets at x equal to 0. Right, we have figured out at x equal to 0, obviously both sides it is 0, right? This black one, greatest integer function of this function at x equal to before 0 and after 0. This is all the straight lines, right? So at x equal to 0, it is continuous. At the same time, -1 to 0. -1 to 0, the value of the function is still 0. So it is continuous here also. Between -1 and 1, it is continuous. After that, it is breaking at every integer. Right? 0 is the only integer where it is not breaking. Otherwise, it will be discontinuous at every other integer except 0. So that is the correct answer. Right? It is continuous in this range. Obviously, because it's a flat line. It's a single flat line, y equal to 0. Flat line coinciding with the x-axis here, and this is actually continuous at x equal to 0. Right? Yes, a brilliant problem, nice problem. Right? We can do the basic algebraic way also without even getting into the diagrammatic way or graphical way. What we will do, we'll take a limit when x tends to x comes from left and x comes from right of 0, x comes from left of 0, and we can say whether it is continuous or not. But it is important for us to understand the graphical significance, or in fact, given any problem like this, we should be in a position to roughly sketch the graph of the function and be convinced thoroughly that whether it is continuous or not. Right, guys? Hope you like this. Thank you.